Okay, I think I'm just going to lay my cards out on the table here. I think building front-end JavaScript applications is insanely hard, right? And there are a bunch of factors that contribute to this. And I think a part of it is that they're just these giant balls of state and events. So I thought it would be interesting to take a bit of a step back and take a look at some of the patterns that we see being applied commonly in JavaScript applications and see if they're giving us ways of handling state and events in a scalable and maintainable fashion. And then what we'll do is take a look at some of the tactics that we can use to build on that to help us better embrace state and events without sacrificing clarity in our architectures. But first, thanks for the introduction, Ben. I just thought I'd introduce myself quickly. I'm not a llama, and I come from New Zealand. It was a pretty long flight, but I'm really happy to be here in Berlin. It's my first time, and it's my first time at JSConf EU, so thanks for having me. It's been a really fun time so far. And if you're ever over in New Zealand, you want to hang out and find out some cool things to do, you can hit me up on the Twitters. I'm a meep on Twitter and pretty much everywhere else on the internet. And like Ben said, I work at GitHub. Now, before I get started, before I really roll into this, I have two confessions to make. My job at GitHub has it has nothing to do with JavaScript. Don't leave just yet. So I spend my days hacking on the native applications that GitHub builds. So I'm on the team that does GitHub for Mac and GitHub for Windows. And my second confession is I'm a Windows developer. Again, just hear me out. Before I was at GitHub, I was writing lots and lots of JavaScript, and I was building apps in Backbone. And in terms of architecture, JavaScript applications in the browser actually have quite a lot in common with the architectures that you find on the desktop. And the thing that ties them together is the amount of state that we're concerned with. Our models, the state of our models, the state of all of the different views that are being displayed on the screen at any given point in time. And in the browser, we're concerned with the state of the address bar. So it's a truckload of state that we're all trying to keep track of. But on its own, state isn't really that interesting. What makes an application interesting and compelling is if we're able to interact with that state. If we're able to force new states on the application, force state transitions. And state transitions are going to occur via events. So for example, we have a form and somebody inputs some data into the form, and they click the save button, and the model that backs that form is going to transition into a new state, maybe an invalid one. And we've got lots of ways that we can make interesting things happen. Lots of ways that we can fire events. DOM events, model events, events that are occurring on our pub sub channels, and routing events. So we've got lots of state, and we have lots of events, and it all needs to be managed. And as the complexity in our application grows, as the amount of code that we have, the amount of features that we need to support, the amount of people we have on our team, as all of that grows, it becomes harder to keep track of all of that state and all of those events. I mean, how many times have you guys seen code which has conflated ideas like models and views? It's conflated state and views. It's conflated state with events. Without a way to separate our data from our views and our state from our events, it all gets intertwined, and we can't test it, we can't maintain it, and we can't change it. And on top of all of that, we're feeling pretty shitty about it too. So without that really solid architectural plan, it's all going to become a bit of a headache. So what do? Rightly so, we take inspiration from other places, design patterns, which have proven to be solved particular problems like preventing spaghetti code. And this is the thing that I really love about software, right, is we're actually able to do this. We can take things that have been applied in one context and apply that in an entirely new one. And because we can do that, because we can take inspiration from elsewhere, design patterns tend to evolve in a really organic fashion. They're like ideas that spread from one place to another and stick because they're funny, like a meme, or because they contain the solution to a really tricky problem. And if you take the MV Star family of presentation patterns, this is no exemption to that. So presentation patterns like this actually originated out of the client, applications that were built for the desktop. So I'm talking about the Smalltalk days here. And then over time, web and web server programming became really popular, and we applied these patterns here as well. And now we're building rich applications inside the browser, and these patterns are being applied here. So we've got frameworks like Rails, which are written in an MVC style, and then we have JavaScript frameworks, which are also claiming to be implementations of MVC. What gives? Well, I'm really not here to turn this into a conversation of like who's doing MVC by the book, because frankly, that's pretty boring. But what is interesting is to take a look at each of these flavors of MV, whatever you want to call them, and see how they're giving us ways of handling state and events in each of the cases, to see which ideas can stick and which ones are causing us too much pain in an evented and stateful world. So let's start out by taking a look at how MVC typically plays out on the server. And hopefully this is going to be a reminder to you guys. Actually, can I see a sea of hands of people who are comfortable talking about MVC? Great. It's most of you. So there were a few hands that didn't go up, so I'll be really quick and just going through the basics. We have our models. They are the guts of your application where all the interesting things are going to happen. We have our views, which are presentations of those models, and it's typically going to be in the form of a JSON or an HTML document, and they're basically representations of a model's current state at a given point. We have our controllers, which are responsible for sending commands down to the model, perhaps transitioning the model state, and then returning a new snapshot, a new view of that current state. Now, routes don't really fit into the traditional definition of MVC, but on the server, they're a really key part of the architecture. Our routers are responsible for matching those incoming web requests and delegating that work off to a controller and an action. So the point that I want to make here about how this all pertains to how state is managed on the server is that it's not, right? Like, we don't have state on the server. We might, but we probably don't. We try and build stateless web applications. And we do this for a number of reasons to scale out across many servers. And we achieve this by persisting to a shared data store of some kind, which begs the question, if we're trying super hard to be stateless, how are we going to make interesting things happen to our data? How do we transition into a new state? Well, we address state via HTTP, right? So we can say, HTTP, get me a list of books at the library. And if we want to delete some of those books from the library, I don't know why you'd want to do that, like watching the world burn seems kind of silly, but if you did, you could say HTTP delete. And what we've done here is we've simulated a state transition across the boundary. We've simulated an event. So in this world, state and all state transitions are addressable via HTTP. So our router matches a pattern, the controller has an action invoked, the model's looked up and maybe has its state transitioned, and then a new snapshot is returned. So what we end up here with is an architecture that is very linear. A request comes in, something may or may not happen to the model, and then a snapshot is returned. So we go down the stack, and then we go straight back up the stack again. So how does this all relate to how the implementations play out on the client? So the key difference is, on the client, we are no longer trying to be stateless. We have all of the state in memory. And because we're only servicing a single user, we can do some pretty great things. We can build a much richer set of interactions. And we keep a bunch of things in memory to help us form this cohesive application. And it comes together to form a very non-linear state space. We have our models, and they're usually coupled with that snapshot that we saw from the server. And then we add an extra layer of complexity on top of that. Validation, security, a lot of other kinds of behaviors. So we have an enormous amount of possible states that our model could be in. On the screen at any given point in time, we have a whole lot of views, each presenting a model's state. And together, all of those views are going to define the overall view state of the application. So what's being presented in the sidebar? Can we edit the person contact view? What's in the main content region? So all of this is adding complexity to the state space that we're managing. And then we have the overall state of the application, right? So these are questions like, which modules are currently invoked? Which ones are no longer being used? Can I clean them up to free that memory? All of this is important stuff that we have to manage. And then, as an added bonus, we no longer have to emulate those state transitions across a boundary. our state and our state transitions occur within the same execution context, and that's really empowering. So on the client, we have a large state space, and we move around that state space in a really non-linear fashion. And that dimensionality should be reflected in the code that we write too, but in the simplest way possible. We need to be able to test and predict how our application is going to behave. So we really need to have a plan. We need to apply some ideas, some patterns to help us achieve this. So just like on the server, we bring over those presentation patterns, our models, our views, and our controllers, or whatever the controller portion is that you've brought over. And then we add routes to the equation. Now, I mentioned earlier that traditional implementations of MVC don't mention routes, and on the desktop this is certainly true. So this is one place where the architectures differ quite dramatically. And so coming from the desktop, I felt a little weird about this at first. I kind of questioned, like, why do we need routes? How do they fit? How do I put them into my architecture without muddying the waters? And it all felt a little weird and unnecessary until I remembered we've got the address bar. Like, we totally need to be able to copy a link, send it to our friend, and they should arrive at the same state that we see. So addressability is still a really key part of building rich single-page applications. So what I want to do now is I want to explore and question how we commonly see routes being applied in JavaScript apps, and take a look at some of the ways that we might structure our code typically. So I'm going to give this example in Backbone. Some of the object names might be a little different in each of the frameworks, and you might not even see some of the steps because they're hidden behind framework code, but the series of events is pretty much going to be the same. So here we're dealing with a party of animals, because party animals are pretty great. We've got an animal model and a list of partying animals. We have a view, which defines a template and a render function, and then we have a router. Now, an interesting fact about Backbone routers is when Backbone first came out, the router object was actually originally called a controller, and I think that's led to a lot of confusion. So we have this router, and it defines two routes, party and uninvite. The party one behaves a little bit more like an HTTP GET, and the uninvite behaves a little bit more like an HTTP delete. So if we hear the uninvite change on the address bar, we're going to invoke this function, revoke party rights. And what it does is it looks into the collection, finds the model in question, destroys it or transitions its state, and then it moves around into the DOM to update the state there. So why is this bad? So we're breaking encapsulation here in order to push everything right up to the top, to the routing portion of our code. We have a view that's responsible for doing some initial rendering, and it has a reference to our model, but the first thing that we do when the delete route kicks off is we do an active lookup of that model, and then we transition its state inside the router. And then in an even crazier turn of events, we use jQuery to reach behind the view into the DOM to update the view state, which feels a little weird. We're really breaking encapsulation here. So we took those flavors of MVC that we saw on the server, and we tried to apply that really linear approach to the client. And in doing so, we broke encapsulation to hinge our design around the need to support routes. So we started to treat state and events, the very thing that gives us that rich client-side experience, we started to treat them like second-class citizens. So we don't need to be manipulating our models like they're rows in a database. Our models can be real and rich and interactive. We don't need to be pushing everything up to the routing portion of our code and subsequently relying on routes to drive state transitions. When routes become an architectural driver like this, it becomes hard to know who's responsible for what. You see, in my mind, routes are a feature. They're not an architectural driver. So the question is, are routes the enemy of the state? They're totally not the enemy, right? We really need routes for addressability, like I said earlier. It's an important consideration in our overall design. The thing that's causing us pain here and with managing state is only using routes as the driving part of our architecture. So we've too closely emulated the designs that worked well for the stateless server, And as the complexity in our front-end apps grows, the cracks in that start to show. So thankfully, I think we can find a happy medium where we can embrace the need for routes without relying on them to drive state transitions. So the first thing I want to do is address that bloated router code example and drop the need to address state transitions via a route. So we still have our models like we did before, but now our view is going to have an event. Did that move? Yeah, it's going to have an event hash. This is nothing new. Backbone has supported this for a very long time. All it's going to do is when it detects a click, it's going to invoke a function on the view itself. It's then going to grab the model that it already has a reference to, transition its state, and then remove itself from the DOM. So we don't have to do any of those unnecessary lookups to find the model we want to delete. And the view is in charge of itself, right? It's in charge of the model, and it's in charge of collapsing itself from the view. Okay, so if we don't want to be addressing state transitions like an HTTP delete, and we still need to support the HTTP GET case, how do we do this in a clear way? So I just want to show you a couple of ideas that are going to help you do this. We're going to take our models, we're going to take our views which render a template, and then are responsible for mediating the interaction between the DOM and the model, and we're going to give that to a controller object. Now this controller object might keep track of a few models and views. That's totally okay. Not many, just a few of related functionality. We're going to take all of that and we're going to slide that into a module. We're going to slide it into a single component per logical part of the application, and we're going to do this for a bunch of reasons. Testability, composability, and frankly, it's sensible. And I really love this quote because it kind of describes the idea behind modular thinking. And it basically says the whole world is trying to build these large applications, right? These complicated apps. And we should just get off that bus right now because it sucks and it's going to nowhere. We should start building smaller apps. And we should be testing those smaller apps individually and then bringing them all together to compose them in a larger application after the fact. And I really like that. So a module is usually defined by a discrete area of functionality, and within that module, it's free to present any view that it wants, raise events, and keep track of its own internal state. And there's several options for implementing modules. You can hand roll your own if you just Google the module pattern in JavaScript. It's a well-discussed and understood topic. You've got AMD modules, CommonJS modules, there's lots of ways. But for me, the golden rule about modules is that while modules are free to present their views, they are never free to directly place themselves in the DOM. That responsibility needs to go to another object, and the reason for that is because we don't want to couple our modules to the state of the DOM at any given point in time. We need to be able to remove one module from one page and put it somewhere else, and it should still function. So the other component that is responsible for making this choice, I'm going to call it a layout composer. And its responsibility is pretty obvious, is to compose the UI. So it's going to define a top-level view, like a shell, with regions that the modules are able to present themselves within. And when a new module is activated, the composer is going to be responsible for swapping the views in and out. So this is an example from an extension to Backbone called Marionette. Can I hands up for people who've heard of Marionette? A few, great, okay. So the way that it solves this problem is it has a region manager, and you can register a region called foo and tie that to an element bar, and it's going to return a region object. Or you can do the shorthand and define them all at once. So here I've got main content region and a sidebar. And then the nice thing about that is you can say main content.show and give it a view, and then internally what that's going to do is it's going to give the element main content to the view, and it can render itself in that place. But I think we can go a step further, right? So we can take our layout composer, we can still add regions, but what we should be giving it is the module. And then the module has a reference to the element that it is going to be rendering its content within, and then it's free to present whatever views that it would like in that region until the layout composer decides it no longer can. So it's going to look a little bit like this. We've got a bunch of modules presenting views at a micro level, and a layout composer that's responsible for composing the many modules that we have running at one time. So how does this placement occur when a new module is activated? How does that work? So the thing that's going to be responsible for giving modules to the layout manager is a dispatcher. And it's going to listen to events which indicate that it's time to load a new module. And on such events, it's going to load the target module and create an instance of it, do anything that it needs to, and then hand it over to the layout composer to place it in the application shell. And one way that we can know that it's time to load a new module is a routing event, right? So in this design, the router is going to sit on the side, and it's going to be responsible for one thing and one thing only. It's going to listen and observe URL changes, and then when it hears those, it's going to look up which modules need to be loaded on the screen at any given point in time, and then raise an event to the dispatcher. So I've taken this code from a library called Chaplin.js. Has anyone heard of Chaplin.js? A few less hands. Another library I would really recommend you busting open the source code for, because it's got some great patterns. And one of the things that it has is a dispatcher. And I've cut this down a little bit to get to the key points. But it describes the previous route, the current modules, and the current route. And then when you create the object, it subscribes to the event route.match. And when it hears that, it basically is going to load the modules. It's going to take the modules that the route has decided need to be loaded, it's going to look them up, make sure that they're running, make sure that they're in memory, and then hang them off to the layout manager. So we tack on the dispatcher, which is responsible for creating modules and also managing their lifetime, because an interesting thing here is that the dispatcher knows that this module A is no longer in use, and we could clean that up, right? So it's not responsible for managing the lifetime. And then it's also responsible for passing those modules over to the layout composer who's going to place them in the overall UI. And one way that the dispatcher knows that it's time to load a new module is that a routing event might occur. And so in this way, the router remains a key feature, but it's not a driver of our architecture. And traversal around our state space can be entirely driven by our events. So we've split up some of those concerns that we've had around state and events, and all of the many views that we're displaying at one time, the state of the address bar. And now we have a much more composable design, where we're using events to transition into new states in a really non-linear fashion. So if that was all too long and you didn't read it because reasons, this conference has been pretty great, and I'm not surprised if your brains are full, I'll sum it all up for you. The management of our state space gets really, really hard when we don't separate our concerns. And on the client, we should use routes to address states, but never transitions. We should be taking ideas from one context to another, because that's awesome. We're programmers, that's what makes programming fun. So we can take inspiration from the server about how we include routes on the client, but it's not a rule book. We need to be able to mold these ideas to support new requirements, like the need to be stateful and embrace events within the same execution context. We don't need to bake everything into the router because it's not scalable long term. And if I had to sum up the point of all of this in one sentence, it would be, don't architect our client-side code like it's a web server, because it's not. Don't build servers on the client. Thank you.